question one. So this is the midterm that I'm sent you from previous summer session for Melissa Saagh. So if we look at the first question, a few years ago, Porter Airlines announced that it would be charging for the first piece of checked luggage for each of the and every passenger. Company had determined that 21% of their passengers had one piece of checked luggage. So they think it's only 21% checked luggage. So in line 4, following the announcement, further analysis determined that the customers who were previously faithful in Porter would now be more likely to simply seek out the lowest fare even if they meant not flying with Porter. Okay, so the domino effect could be the overall lowering of revenues. A poll was conducted, they found 707 of 1,039 consumers who would lessen their loyalty to the company of the new charge. We need to do a 99% confidence interval for the proportion. So we need to do in A 99% confidence interval for proportion of those who would lessen their loyalty. Now, confidence interval for proportion, we use the following. There's only one formula we could use. Which is P plus or minus Z star square root PQ over N. Now, to do the Z star, we need to know what Z star is at 99%. You could Google it. If you say Z value 99% confidence interval, it will tell you. I also showed you the other ways to do it. Well, basically, after you do it, whatever technique you like, this will give you 2.578. And you can also, or 576, sorry. And I showed you the different ways of doing it. Now we also need to find P. P is the result of your sample. So that's 707 over 1,093. So you take the calculator, put it somewhere here, I believe. Yep, here it is. So 707 over 1,039. This percentage is 6805. And Q is always 1 minus P, so it's 1 minus the 6805. And that would give you 3195. So we have everything we need. We put everything in the confidence interval. So P 6805, the Z star is 2576, the P6805 times Q 3195 and the sample in the question 1039. As we know, this number we bring down, we do the confidence or the margin of error, what comes after the plus minus. And this will give you 0373. Then your estimation for pi, you add the two numbers, you minus the two numbers. 6805 minus 0373 takes you down to 6432. And when you add them, it takes you up to 7178. And of course, anytime you do a confidence interval, you also have to interpret what it means. So you say in 99% of confidence intervals, based on 139 customers, the true proportion of customers or consumers who would lessen their loyalty due to the changes or the charges is between, and you put the two numbers, 64 and 71.78%, with 1%, since we're 99%, you say with 1% chance of good? So, that's the answer for the question. And it was only a one-part question. I also want you to keep in mind, this question was obviously from the confidence interval. It says confidence interval for proportion. So we know it's one proportion, and right away it's this formula. Let's say that they talk about two different samples, men and women. So let's say they talk about men and women, they tell you 120, 140, and they tell you 70 of the men like the new system, and here they tell you 80 of the women like the new system. So you have two proportions. Proportion number one would be 70 out of 120, and proportion 2 would be 80 out of 140. They could ask 95% confidence interval for difference between proportions. If they say confidence interval difference between proportions, it would be P1 minus P2 plus or minus Z star P1, Q1, N1, P2, Q2, N2. So you need to make sure, is it a confidence interval for proportion? Or is it confidence interval difference between two proportions? And the procedure of how you do this, pretty much the same. So, we go to the next one. question number 2 in the midterm. So question, when border complemented charging for the first checked bag, a survey was conducted. A portion of the results of the survey are summarized. So they give you a cross-reference table. Carry all, checked all, do both, no luggage, versus the primary reason, business, emergency, moving or transient, and pleasure. And they give you all the different numbers. So you have two different variables, baggage disposition versus primary reason. At 5% level of significance, is there evidence of significant relation between type of feature desired and type of accommodation? Well, I should say type of baggage disposition and type of primary reason. You need to state the hypothesis, the critical, and the test value. You don't need to actually solve it. Now, since the information in this question are cross-referenced like this, so we think that it could be chi. And then we look at the inside numbers. So the 653, the 47, the 6, the 62, the 83, the 14, the 78, the 417, all these numbers. These are counts of baggage. So it's something you count. When you have the information cross-reference and the inside numbers represent count, you have chi-square. And how can you make sure that they represent count? You ask yourself, could these numbers be like 10.5 or 10.3 or 5.7? No, they must be a whole number. They must be integers. So these numbers are count, no problem. And the question is asking about relationship. Sometimes they could ask for dependence. So you put H0, HA. For relationship type or dependency type confidence interval, here you say no. There is no relation between and the two variables, baggage disposition and primary reason. And here we say yes, there is a relation. And if it was in terms of dependency, no, baggage disposition does not depend, here does depend. So it's always, whether it's relationship or dependency, it's always H0 no, HA the yes. Now, in the next part, what's the critical value? So we need to do the critical value. Which is basically the decision rule. Chi is always one tail, upper tail. So you say this. If chi squared test, if it's more than whatever the table number is, we're going to reject H0. Now, I believe that she provided a chi test or a chi table. To get the number from the chi table, we need to know degrees of freedom and what alpha is. For this type of chi, degree of freedom are rows minus 1, columns minus 1. So you go back to the actual question. You look at the table provided. How many cases do we have going this way? How many rows do we have? We have business, emergency, moving, pleasure. Don't count the total. So there are 4 rows. How many cases we have going down? We have carry all, check all, do both, no luggage. We also have 4. So that's 4 minus 1 as well. 3 times 3, degree freedom is 9. Alpha, in the question they tell you at 5% level of significance, so your alpha is 0.05. You can use the chi table you have. I use this. They're all the same pretty much. You go to degree freedom 9 and 5%. In my table, it's 1692. And your table might be a little bit different, and it's actually, maybe you'll see it instead of 92, because 92 when it's rounded to 2 decimal places. Yours might say 91898 or something. That's the most, this is the most accurate number. So that would be the critical value that we get from the table. And in the next one, what's the test statistic that you use here? A lot of people thought that you have to do the calculation. No, she mentioned up top that she doesn't want you to do the calculation. All you wanted to do is to name the test. So just say it's going to be chi squared and the formula, so put the name, and the formula is sum of O minus E squared over E. You also see this in your formula sheet. It's the chi square formula of the summation of O minus E squared over E. And that's all you needed to do for this one. So just provide what the test is. And that's all. The only thing that I think that she could change in this question, she could say, assume that the chi-square test is 20.39. What your conclusion? So she might ask you, well, what if she gives you that, like if it happens to calculate the chi-square, what if you end up with 23.9? What would your conclusion be? So if you end up with this number, your conclusion would be, say, conclusion. Chi-test of 23.9, that's more than 16.91898. So the condition here is satisfied. We're going to reject H0. So the condition is satisfied. We are, in fact, rejecting H0. Anytime you reject H0, you have to mention type 1 could be committed with risk equals alpha, and it's whatever given in the question, 5%. The last thing she could ask for is what the p-value is. P-value chi, or even p-value t, it's dtt. Degrees of freedom, test, and tail. We know it's a degree freedom 9, rows minus 1 times columns minus 1. They give us the t-test, and it's one tail because chi is always one tail. I'm going to use my chi table. You go to the degree freedom 9, and you look for this number. In my table, in degree freedom 9, this number is more than 18, less than this, so it's between two of the numbers I see in my table, somewhere between them. I go up, so my p-value somewhere between 0.25 and 0.5. So when you go and look in the degree freedom 9, you'll see that your number, this number, is somewhere between two numbers. You go up, and whatever the two percentages are, that would be your p-value. And if your number is more than the table, your p-value less than whatever the percentage on the last percentage. And if your p-value more than the table here, it would be more than the first percentage. So there are three cases for the p-value. I'll talk about them quickly. Let's say, for example, at degree freedom, say 10. You have the numbers, say 2, 5, 2, 2.5, 3, 3.5, 4. This is just we assuming. And this works for chi and for t. And percentages say this is 40%, this is 20, this is 10%, this is 5, and this is 1%. If your test was 3.7, so it's here, then you say my p-value between this and this. If your test was 2.8, here you say p-value between 10 and 20%. Your test happens to be 5.3, like here, outside the table. All you need to say it's less than 1%. Anytime it's more than the table, it will be less than the percentage. And if your test is 1.2, like here, less than 2, you'd be more than 40%. So here you're more than this percentage, and here you're less than this percentage, and if you're between, you'll be between the two percentages. And that works for chi and for t later. Okay. Now we go to the next question. question 3. There are two major companies that provide saagh test tutoring for high school students. The issue is whether Company 1 has been in business for a longer time, provide better results than Company 2. The newer company, especially, of interest is whether the mean increase in saagh score for students who have already taken the saagh test one time is higher for Company 1 than Company 2. So they want to see if the score by Company 1 is more than Company 2. A test is conducted at 10% level of significance, and the following numbers provided. So they give you everything. They give you the information for Company 1, and you have the information for Company 2. You have the numbers here, you have the numbers here. And you also have all the different summary numbers. Now, you have the sum of x, the sum of x squared, all of this. Hypothesis. So, H0, HA, or H1. Now the question here is, do we have two sample dependent or two sample independent? Are the 8 students, so we have 8 students here, and we have also 8 students here. Are they the same 8 students or different? If you look at the information, you have 2 different samples. 8 students using the services of Company 1 and different. It's not the same 8 students. So there are 8 students here and different 8 students here, using the help of Company 1 and then using the help of Company 2. When you have 2 separate groups or 2 different groups, you have 2 sample independent. So if you're proving that Company 1 more than Company 2, you say mu1 more than mu2, and if you bring it over, it would be mu1 minus mu2 more than 0. This one would be the complete opposite. In English, true mean score in saagh for students using Company 1 is not more than those who use Company 2. So this one says that 1 is not more than 2, and here, more than 2. So again, here we say 1 is more than 2, here we say 1 is not necessarily more than 2. Now, step 2 in any hypothesis is you determine what test you would use. The test we would use, if it's 2 sample independent and there are no sigma, we don't know what the standard deviation is for all students, so we're going to use average group 1, average group 2, mu1 minus mu2, SP 1 over N1, 1 over N2. And you'll see this formula in your confidence, you'll see it in your formula sheet. Now, decision rule. According to this, when you're more, that makes it 1 tail, upper tail. If you're less, you're also one tail, but lower tail. Not equal would be the only time that is two tail. So HA is 103. You're either going to prove more, that would be one tail upper, or proving that you're less, one tail lower, or proving not equal, and that's two tail. So here we have one tail upper, so we say if t-test more than the table, we're going to reject H0. Now, to get this number from the table, to get this number from the T table, again, you need degrees of freedom, and you need what alpha is. Degree of freedom for this would be n1 plus n2 minus 2. Only for the two sample independent, we add them minus 2. So it's 8 plus 8 minus 2. So 8 plus 8 minus 2, it's 14. And we're doing this question. Let me look at the question and see if they give us a certain alpha to work with. I don't know if alpha was given. Even if it's not given, you use 5%. Yeah, but they give it to you in the actual question, line 4, using 10%. So alpha is 10%. You don't divide it by 2. You leave it as it is, since it's one tail. So you go to your T table. I'm going to use this T table. Go down to degree freedom 14 with 10%, one tail. Number is 1345. So number you get from the table would be 1.345. Okay. Once you're done, it's time to do the calculations. Now, to do the calculations, you need average of company 1. We can use the sum over n. They give you in the actual question, for company 1, the sum is 428, and there are 8 students. So 428 over 8, 53 and a half. We also need average company 2, which is sum over n. For company 2, the sum is 275 over 8. And that gives you 34375. So we have the averages. What about mu1 minus mu2? Well, anytime in any formula, the top right, you go back to your hypothesis and you'll see a number. So it's 0. Is it always 0? Most of the time, unless she wants you to prove that company 1 is better than company 2 by 4, then this number would be 4. But usually it's just one better than the other, and whatever the number is, you put it here and it's usually 0. Sample 1 is 8, sample 2 is 8. We need SP. If you look at the formula, there is a formula for SP, and it's the square root of standard deviation 1 squared n1 minus 1, standard deviation 2 squared n2 minus 1, over n1 plus n2 minus 2. This is the formula we use to find standard deviation pool, or SP. But standard deviation 1 we don't have, standard deviation 2 we don't have, but we have the information. So to do standard deviation for the first company, we do for the first company the total variations, which is sum of x squared over n. The sum of x squared for the first company is 30916, and the actual sum is 428. You square this, divide by 8. 30916, 428 squared over 8. That gives you 8018. From this, you figure out what the variance is, which is you just take this divided by n minus 1. So you take the 8018 and you divide it by 8 minus 1. So you divide it by 7 basically. You get this number 11454286. And your standard deviation would be the square root of variance. So you square root this number, you get the standard deviation, and that's 338442. So I'm gonna go here. Standard deviation 1 is 338442. We do standard deviation for company 2 now. So when you do it for company 2, numbers are different, but we do it the same procedure. So we take whatever the sum is. For company 2, it's 11873. The sum is 275, and it's 8. So 11873, 275 squared over 8. It gives you your total variation, which is 2,419,875. You divide it by sample minus 1. So you're going to take this number and divide it by 7. That gives you your variance of 3456964, and you square root it to actually find the standard deviation. So you square root the number and you get your standard deviation of 185929. So 185929. So we found the standard deviation 1 and standard deviation 2. We can find SP now. This is average company 2. SP, using this formula, take the first standard deviation, square it, and whatever times the sample 8 minus 1. Take the second standard deviation, square it, sample minus 1, and then you add the samples minus 2. So 338442 squared times the sample minus 1, and 185929 squared times sample minus 1 over, then that gives you your SP of 27305. So that's basically your SP. Now once we have all the information, we can put everything together in the t-test. We need average of group 1, and that's 53.5. Average group 2, 34,375. Difference between mu1 and mu2, we said 0. We need SP 1 over the first sample, 1 over the second sample. So we do the calculations now. 53.5, 34,375, and 1 over 8 plus 1 over 8. And putting everything together gives you a number of 1.4008. Just wanted to make sure that I did the calculations right. So, $53.5 minus 34,375. In the bottom we have 27.305 times square root 1 over 8 plus 1 over 8. Yeah, I get 1.4008 for the answer. Okay, so we have the answer for this. We can make a conclusion. So your t-test is 1.4008. Conclusion. T-test of 1.4008. Is that more than the 1345? Yeah, definitely more than 1345. Condition is satisfied. Reject H0, and anytime you reject, type 1 could be committed with risk equals alpha, and in this question it was, I believe, 10%. So if you're rejecting H0, you'll be accepting HA. Yeah, company 1 is more, because remember, this one is not more, this one is more, so we say we have enough evidence to show that mean score in SAT is more for company 1. Okay. There are other stuff that I want to add to this question, but I'm gonna stop the video because it will, if I just keep it going, it will be hard for me to upload. So part 2 will continue with this. See you in part.